going to discuss about how to calculate the enthalpy change. Okay, I'll give you one example from your workbook. If we have the reaction between methane and oxygen is exothermic. So this is the reaction. CH4, it means that 1 mole of methane react with 2 mole of oxygen will produce 1 mole of carbon dioxide and 2 mole of water. Is exothermic. Why this is exothermic? Because the enthalpy change sign is negative. If negative means that release energy or it is exothermic. The standard heat of combustion of methane is negative 728 kilojoule per mole. It means that it release energy, this number, this amount of energy. So you want to solve this problem. How much energy that is released if we have 2 mole of methane? Given is 1 mole, but we need to calculate the energy for 2 mole of methane, 0.25 mole of methane, 8 gram of methane, and 64 gram of methane. And in part B, we need to draw an energy level diagram to represent the complete combustion for 1 mole of methane for this equation. So it's easy, guys. To make it simple, you need to understand the questions by write down given. What is given? Given is this equation. Just copy paste this equation. Okay, given 1 mole of methane plus 2 mole of oxygen will produce 1 mole of carbon dioxide and 2 mole of water molecule and release 728 kilojoule per mole energy. Release means that negative sign. And then we need to calculate 2 mole of CH4. What is the enthalpy change? How if we have 0.25 mole of methane? Calculate the enthalpy change. How if we have 8 gram of methane? How if we have 64 gram of methane? And draw the level diagram for 1 mole combustion of methane. That's easy, guys. So this is the analogy. If we combust 1 mole of methane, this is the energy that it released, negative 728 kilojoule per mole. Then how if we burn 2 mole? Of course, the energy gonna be double. Okay, so just multiply 2 mole multiplied by negative 728 kilojoule per mole because we release energy. That's the meaning of this sign. So we need 1456 kilojoule per mole of energy. Or this is exothermic reaction because the sign is negative. Do you understand? Yeah. How if we have 0.25 mole of CH4? It means that 1/4 of this. Then just multiply this energy multiplied by 0.25 or this energy divided by 4. So the answer is negative 182 kilojoule per mole. Don't forget the sign is still negative because this is exothermic reaction. This is quite different, but I think you understand. How if we have 8 gram of methane? Then you need to convert gram into mole. I believe you still memorize the mole calculation, how to calculate the mole. That's true. Mole equal to mass in gram over molecular relative. So we need to calculate the mole of CH4 in here. We have 8 gram over, calculate the MR of CH4. You need to check your periodic table, yeah. So 12 plus 4 times 1 if you check your periodic table. So the answer is 0.5 mole. And then 8 gram of methane means that 0.5 mole of methane. It means that this energy divided by 2 or 0.5 mole times negative 728 kilojoule per mole. So we get the energy is negative 364 kilojoule per mole, and this is exothermic reaction. Next, how about we have 64 gram of methane? How many energy that we need to release? The same thing, you need to convert this 64 gram into how many mole? Okay, 64 gram over molecular relative of methane, which is methane is 16, so we get 4 moles. Just multiply 4 moles multiplied by minus 728 kilojoule per mole, so we get it negative 2,912 kilojoule per mole, and this is exothermic reaction. Now we need to draw the energy level diagram for 1 mole of CH4 complete combustion. Okay, so because this is exothermic, so the position of reactant, this is the reactant guys, this is reactant and this is the product, and this is the enthalpy change. Reactant copy 1 mole of reactant of CH4 plus 2 mole of oxygen will produce carbon dioxide and 2 molecules of water. So don't forget to label x-axis as the progress of reaction and y-axis as energy in kilojoule. And which one is the enthalpy change? Is the gaps between reactant and product. So enthalpy change for 1 mole of methane equal to negative 728 kilojoule per mole. And this one, the peak to the reactant, we call it as activation energy, the minimum energy that is needed so that this reaction happens. And enthalpy change means that the energy that is released after this reaction happens. I think that's it for the calculation guys, and then try to do the exercise that will be given for you. Bye.